will continue where we have left off. As always, Rustlings watch. And as you can see, exercises, structs 1. So, Rustlings, exercises, structs 1. Like that. Let's see. Address all the to-dos to make the test pass. So here we have a struct, color classic struct, to do something goes here, color tuple struct, unit like struct. So we have 3 types of structs. The first one is a normal OG struct, the second one a tuple struct, and the third one unit like, which actually we don't have to do anything here. It's fine like that. And here we have our tests. So here we have also to-dos, instantiate a classic C struct. Okay, and here you see the assertions. The struct name is green, so we access these members, and here are the values that should be in there. Here the same thing for the tuple struct and the unit struct. Okay, so we'll start here. We have a color classic struct, and maybe so you see like that, we can actually see in here, this would be the classic struct, so it will have 3 it would have 3 members, and the first member will be red, and I will make them I32 because they won't be a negative number, so no need for unsigned. So green I32 and blue I32. So in the last member, it's optional. If you want, you can do a comma. If you don't want, you don't need to. I like it because if I want to add another member, I don't have to worry to put it. I can just make another member. But as you like. So actually this is done. Then here we have a tuple. I guess I will now close that. And here tuple struct, they don't have a member name, so we just can initiate it like that. That's a tuple struct. It's basically a struct, but it doesn't have member names like here. The members are just in a tuple. And a unit like struct, and unit like structs don't have any member. So you just put a semicolon directly after the struct name. So the next to do would be, let's see, instantiate a classic C struct. So let's see, we will go here and just create this struct. So let's see, color classic struct, and we will just color classic struct like that, and we have here, over here we have the values. So red will be 0, green will be 255, and blue will be 0. That's it. After this we need a semicolon, because this is actually a variable over here we are declaring, so it needs a semicolon. And here instantiate a tuple struct. So let's do that like this, and the name is color tuple struct. So color tuple struct, and we just pass the values over here. As you can see, we are accessing them here. So index 0 will have 0, index 1 will have 255, and second index will have, or index 2 will have 0. And here instantiate a unit like struct. Okay. This is pretty easy. We just unit like struct, the name of the struct, semicolon, and it should compile. So that's it. We have done that. So as you can see, we just made these structs over here. We have declared it, and then we make, or we have made instances of these structs. So this is an instance. This is an instance of this struct, this is another instance, you know, and then we passed values like over here, over there, and that's basically it. Okay, the second one, structs 2. So address all the to-dos to make the tests pass. So we have a struct named order, name, year, made by phone, made by mobile, made by email, item number, and count. As you can see, we have booleans over here, we have unsigned integers, we have string, and then over here we have a function. All right, and this will create a template. So as you can see, we are returning order, struct of type order, and here we have basically the values put into that, so that will be returned. And now the to do. So here we create an order template. This will be a template, so this will have a type of order like that. Create your own order using the update syntax and template above. So let's see. Let your order, and we will make a new order like that. And now what we actually can do is, or we can just call create your own order using the update syntax and template above. So what we can actually do is create an order like that, the semicolon over here, and as you can see over here in the test, your order name should be hacker in Rust. So we put this over here, name hacker in Rust, or we have to make that a string, I guess. All right, so we will do it like string from enter in Rust. That's it. Then your order count should be 1. So count, we will do 1. And as you can see, the rest of this variable, your order should have the same values as this template. So all we can do now is just making it like that, and we type order template, and it should actually work. And we have to remove this comma actually. So this is an exception. If you have this syntax, you're putting the rest of the order template over here. You can't have a comma at the end. And it's compiling. As you can see, instead of just writing everything from this template, for example, year or made by phone, we can just take it and put it here, and the rest of these things that won't be the same, for example, name, we have here another value than over here it's Bob, so we have to modify it, and the rest will get applied from this template. All right, that should be it. Now, this isn't actually the greatest way of solving it. The better way would have been if you made this inside an implement order, and you put that inside another like that. You go upside and put that over here. So like that over here, and as you can see, we have made that, and we have now a method for the struct order. So we can actually just create one like that. So we can here order and like that, and it should compile, I guess, and it's compiling, as you can see. Right, we have just made this a method of this struct. I guess it makes a lot more sense because it's actually connected or in a relation with this struct. So this function is always related to this struct, so it makes more sense if you made it like that. Also, you can see here you're making create order template is actually over here, and you even don't need order here actually, because you know it's clear when you see order. So we can modify that like that, for example, create template. And here, by the way, instead of typing order, we can write self, but that's not really important. Self in this case will be order because it implements this method on the struct order. So here we also have to change that like that, and it should compile, and it's compiling. All right, That's not even really necessary. You can do it like that if you want. You can keep it like it was. It's just, it makes the code a little bit more readable and organized, but as you wish. And the last one. Structs contain data but can also have logic. In this exercise we have defined the package struct and we want to test some logic attached to it. Make the code compile and the tests pass. So we have a struct here, package, it has sender country string, recipient country string, and weight in grams integer. And actually here we have an implementation for struct package. So this will be a method on the struct. And here we have a function new. It takes the sender country, recipient country, and weight in grams. Basically, these members over here as arguments. You can pass it and it will create a package. And will return it. I will make it like that so you can see it better. It returns a package. We can make that self. It's not that important. So here we have it firstly tests if weight in grams is less than or equals 0, cannot ship a weightless package. And it will panic. And panic means the program will immediately stop and it will throw out an error. So it makes sense here because who will send a package with 0 grams, right? And else this package struct or instance will be created. So is international, we have to implement that, and get fees. And to get what it is needed here, we need to take a look into the tests. So for example here, this should actually panic. We have here sender country Spain and recipient country Austria, and we create a new package that's with this method, with the new method, and we pass it sender country, recipient country, and we pass it a number, a minus, a negative number. So this should actually panic because we have said if weight in grams is less than or equals to 0, it will panic. So okay, then create international package. So here we have sender country Spain, recipient country Russia. So this is international because it's not the same countries, and this is fine because it's a value above 0. And here you see the test package is international. This should be return true. So all we have to do here is this will return a bool and is international. Actually, we'll check. So we have self, and self basically means you are taking the instance. For example, here the instance of the struct package is package. So here this would be self. This is actually replaced by self over here because self is just abstract for the instance. So self dot sender country is not equal to self dot recipient country. We don't add a semicolon because we want the return of type of that, and it's a bool. Or better to say not the type, but the value, the return value, and this will be of type bool. Okay, and the second one, get fees. And here, you know, we see create local package, so Canada, and we have a copy of that, so it will be Canada 2 in recipient country, and this should actually be false. Okay, and now calculate international, create local, calculate transport fees. So we have from Spain to Spain, sender country, recipient country, cents per gram 3, and we pass it here, package, we make a new package over here, and get fees cents per gram. We pass 3 to it, and it should return 4,500. That's 3 times 1,500. All right. So all we have to do here is actually we have self, and we have the weight in grams, and we will multiply it by this argument cents per gram. This, I guess, it will return an I32. Let's see. And it's compiling. So we have now implemented all the methods, and we have passed all these tests. So let's delete that. So I forgot actually to delete this one. All right. So we've actually, if I undo that, as you can see, it compiles. That's structs, structs 3. All right, and the next topic will be enums. See you then, and good evening.